Okay, well, then we're going to lean on this a little bit and just a few definitions that follow from this. For one thing, we can ask what an angle between two vectors is. And while you might only believe this in R2, it certainly seems valid in R3 too to ask what the angle between these two vectors is. In R4, maybe you're suspicious, and I would say that's warranted, but it's still true, and it's true in Rn. So we can say find angle between, say, any two vectors. So I could say between, say, 1, 1 and 1, 4, for example. And I could do this by saying cosine theta using the identity. Cosine theta is 11.14 over the length of these. So that's square root of 2 times square root of 17. So I get 5 over square root 34. And this is some number between 0 and 1. So I know the angles between 0 and 90 degrees, and I could look this up. Okay, so it's almost 5 over 6, right? So it's pretty close. It's less than 45 degrees between these. Okay, so you can just write theta as the cos inverse of this. Okay, unit vectors. Because we have the length of a vector, we can make a unit vector, which just means, so unit vectors lie on unit circle or unit sphere, or in dimensions, if n is 4 or bigger, we call it unit hypersphere. Okay, so they have length 1. So any vector I have, I could find a vector in the same direction that has unit length. So for example, 1, 4 would be 1 over 4 up would be something like this. It has length square root of 17. And I could just find the one that has unit length by dividing by the length. So we could say, and you could just take it out here. Okay, so that's a unit vector. Okay, good. If I know a vector is a unit vector, I can, especially in R2, we can describe it with just its angle. So that's kind of important. So in R2, a unit vector may be fully described by one number. Say theta, the angle it makes with positive x-axis. So if I have some vector here and its unit length, so say I know length of v equals 1, then all you have to do is tell me this angle, and I know the vector fully, right? So theta. So v, in this case, must be equal to cosine of theta sine of theta. Okay? All right, so far so good. So, for example, let's say as an example, suppose I tell you find coordinates v1, v2 of v equal v1, v2 if v equals 1 and it makes a, let's see, 210-degree angle with positive x-axis. Okay, well, you just have to remember from high school that that would mean this would be a 30-degree angle here. 30-degree angle, something like a 30-degree angle here. This is 1. The length here is 1. So remember, the smaller is a half. And this would be root 3 over 2 here. So that's it. So a solution, v equals minus square root of 3 over 2 minus 1/2. Okay, well, if you allow us to use the identity, the cosine identity, then we can prove the Cauchy-Schwarz inequality very quickly. If you think that's cheating, you're free to prove it without the identity. I could help you, but let's use the identity. So let's say since u dot v equals u v cosine theta, we know that the absolute value u dot v is equal to the absolute value of this side, but these are positive factors, positive numbers that are multiplying, so I just have this. And I know this is positive, so this is greater than 0. Well, if they're the 0 vectors, it could be 0, I guess. And this is also greater than or equal to 0, right? This, in fact, is between 0 and 1. So between 0 and 1. Okay. Right? So absolute value u dot v is less than or equal to this. So this implies this is called okay, so this has many uses, only some of which we will see. We will see some of this. So, one use is I can actually use it to show the triangle inequality, which is next. So, triangle inequality says u plus v is less than or equal to u plus v. So because each side is positive, so the proof is both sides are positive or non-negative. So we show is less than or equal to okay. So to begin, what do we have? We have u plus v squared is equal to this dot product. Now, to do this, let's do it carefully. I have u1 plus v1, un plus vn, dot, 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 dotted with u1 plus v1. All these in here too. And when I do the multiplication, we just get u1 plus v1 squared plus dot, dot, dot plus un plus vn squared, which this should remind you of the cosine proof we just did. This is equal to, we'll see, you can see here, this is, I get the u1 squared, I get the u2 squared, I get the un squared. So I get u squared. I get the v1 squared, I get the v2 squared, so I get plus length of v squared. And what do I get in the middle? This time I get plus 2u1 v1 plus 2u2 v2. So I have plus 2 u dot v. Okay? Sorry. So that's equal to that. On the other side, we have u plus v squared is equal to, I get the u squared plus 2 u v plus v squared. Okay? And so I'm trying to show that this is less than or equal to this. Okay? So let's call it triangle inequality this, and we see, we'll call it star. So we'll see star is true if and only if, due to these steps here, this is bigger than this. So if and only if u dot v is less than or equal to the length of u and the length of v. But this is true due to the cosine formula, right? Because the cos of theta is between 0 and 1, and this is the Cauchy-Schwarz inequality. So this is true by Cauchy-Schwarz. Okay. All right. Okay. Stay tuned for one more.